Let's now continue our discussion on interpretation of multiple bonds in an attempt to assign absolute configurations. In other words, in order to assign priorities, if you like, based on atomic numbers. In general, this time we take a carbon-nitrogen triple bond, a carbon-nitrogen triple bond where carbon has a triple bond with nitrogen. Now this can be interpreted like this. Of course, carbon has a triple bond with nitrogen, so this is like it should be broken up into 3 single bonds. Multiple bonds are viewed as single bonds. A double is viewed as 2 single bonds. A triple is viewed as 3 single bonds. So if carbon has a triple bond with nitrogen, so it's like it has 3 single bonds with nitrogen. So something like that with respect to this carbon. This nitrogen now has a triple bond with carbon. So nitrogen, carbon, nitrogen, carbon, nitrogen, carbon, because nitrogen has a triple bond with carbon. So it's like this nitrogen has 3 single bonds with carbon. That's 1, 2, and 3. So this is an interpretation, if you like, of the C-N triple bond in this task, if you like, of assignment of priorities in the determination of absolute configurations. Now, if you take a ketone, or let's take an aldehyde, for example. That's an aldehyde. The aldehyde can be viewed as something like this. Now, this carbon has a double bond with oxygen. So it's like 2 single bonds. So that's carbon oxygen, and that's carbon oxygen. This carbon also has a bond with hydrogen. So that's the hydrogen. Now, we consider that oxygen, we assume that this oxygen is one of these. So if it is that one, for example, so this oxygen is this one. Now, as far as this oxygen is concerned, it has a double bond with carbon. So OC and OC. So that's one OC, and there should be another. So that's OC. So one bond and one bond's OC, of course, because oxygen has a double bond with carbon. So it's like 2 single bonds with carbon, OC, OC. So this is, again, a detailed picture, if you like, of this aldehyde functionality. We can take a carboxylic acid, something like that. And now if you look at the carboxylic acid, of course, the carbonyl group should be treated similarly. So carbon with oxygen, and of course oxygen, that's because carbon has a double bond with oxygen, so it's like 2 single bonds. Oxygen, carbon, that's a double bond, so OC and OC, and this carbon, the first carbon, has a single bond with oxygen, which has a single bond with hydrogen. So this is a detailed picture of this carboxylic acid functioning group. So this is how we treat multiple bonds. We treat them as single bonds. So we write them in details. This is how they should be interpreted until we reach a difference between 2 specific multiple bonds, multiple groups which have multiple bonds, or even a group which has a multiple bond and another alkyl group in an attempt to assign absolute configurations of R and S. And we'll continue on, of course, in the coming lecture.